All right, so we're going to be continuing the concept of linear functions. Functions are things that we've been talking about all this school year and even in Algebra 1. You're already familiar with y equals mx plus b, so I'm just going to use f of x equals mx plus b. Remember, f of x is the same as y equals. And we know that m is our slope, b is our y-intercept. So it says match the situation to its corresponding graph. So we've got these graphs, and the first situation is that the noise level of traffic decreases after the evening rush hour. So you should be thinking about slope. Which of these two graphs shows a negative or decreasing slope? Well, this one goes down and to the right, so that would be a decreasing slope. So the answer is graph C. Now, this is telling me that the x-axis represents time, and the y-axis is representing our noise level. Right? So you could set up a linear function that would say, all right, over time, as time goes on, after the evening rush hour, the traffic noise level goes down. All right, this one is saying the helium balloon is released into the air. So if you think about a helium balloon, what happens? Well, it rises up, or it floats. So if you were to graph it, if you consider your x-axis to be time, what's happening? Like our altitude or our height of the balloon is increasing over time. Eventually, if we let time go on, this helium balloon is going to just stay at a certain level and then go back down. But for now, we're saying that it's going upwards. So that would be graph B. All right, third problem says a plumber charges $100 plus $50 per hour to fix something in the house. So you're going to write an equation. These are all linear functions, so you're writing an equation that is f of x equals mx plus b. You're going to create a table of values, and then you're going to draw a graph to model this situation. So you should remember from first semester that when we see per, that usually indicates our slope. So my slope is 50. All right, so I'm going to write 50x. Plus, they charge $100 basically for the guy or girl to come out to your house to fix your plumbing. So that's like your flat fee. All right, so our function is f of x equals 50x plus 100. So this is our time per hour, or a money per hour that we're spending or being charged. This is our upfront cost, or our initial fee, something like that. That would be our y-intercept. All right, so if this is our scenario, then what does x represent? Well, x is representing per hour, so x is the number of hours. And what does f of x represent? F of x is our y, so that represents the total amount that you have to pay. So we'll call that our total cost. All right, so in my table of values, I'm going to say we have hours, which is our x, and instead of y, I'm going to use f of x, but it's the same thing. Remember, f of x equals y, and that's our total cost. All right, so if I start off with 0, just for the plumber to come to my house, I'm going to pay $100. Right? If I didn't know how I got that, I would be doing f of 0, that's 50 times 0 plus 100. And if I could put that in my calculator, I get 100. All right? What happens after a 1 hour? Like if I have some job that takes 1 hour for the person to fix. Well, I'm doing f of 1. So 50 times 1 plus 100. It's 50 plus 100, that's 150. All right, so we can keep going. We could also use our calculators for this. So you could do this a couple different ways. Either to do 2 hours. I'm substituting in 2 for my x. So what I could do is I could just say 50 times 2 plus 100. That gives me 200. All right. Or if I want to just graph it, right, I'm going to say my equation is 50x plus 100. Now I don't actually have to graph, I just need my table. So if I go to my table, I can look at, well, at 0, got 100, 1 is 150, 2 is 200, 3 is 250, and 4 is 300. Okay, so let's do our graph now. So this represents the number of hours, and y is the total cost. So we're just going to plot these points. So at 0 hours, it's $100. At 1 hour, it's $150. 2 is $200. 3 is $250, and 4 is $300. Okay, so I could draw my line. Here, I'll even use a ruler. And we'll put an arrow on at the end. Because theoretically, it could go on forever. Like, it takes, hopefully someone's not working for 24 hours to try to fix something, but you never know. All right, so the last question, how much will it cost if he is there for 3 hours? Well, if he's there for 3 hours, it'll cost $250. All right, flip over to the next page. All right, so you have a similar problem. Janet is rowing across an 80-meter river, and her information is listed in the table. Find the equation of the distance that she has remaining before she reaches the other side. All right, so we want to do something that's linear. All right, so at 0 seconds, or before she even starts, right, at 0 seconds, she's 80 meters from the shore. This is her starting point, right? If she starts here, that's my y-intercept. So my y-intercept should be 80. Okay, after 1 second, it's 77. So how far has she gone? Well, she's decreased by 3 meters. After 2 seconds, she's got down to 74. Well, she's decreased by another 3 meters. And here, from 74 to 71, it's another 3 meters. So every 1 second, x represents our time. So this is our time in seconds. Every second, we're decreasing by 3 meters. Okay, so this is our f of x. Here's your equation. F of x equals negative 3x plus 80, where x is the time in seconds, and y, or f of x, represents the distance from the shore. Okay, so how long until she reaches the shore? Well, when she reaches the shore, she's going to be 0 meters away, right? So we need to find out when that is. So here's your f of x. We don't know x. You're going to substitute here and make that 0. And we need to solve. Okay, so 0 equals negative 3x plus 80. So I want to subtract 80 from both sides. I get negative 80 equals negative 3x. Then I need to divide both sides by negative 3. And I get x to equal 26.6 repeating. So we'll say 26.67 seconds. If you want to use your calculator, you can graph this one, or at least get the table of values for it. Right, negative 3x plus 80. And if I go to my table, right, I could look at what happens at 26 seconds. Now, this isn't going to give you anything very accurate, because I know at 26 seconds she's still 2 meters away. At 27 seconds she's in the negative, which means she's already reached the shore, and she's walking inland, I guess. Okay, so somewhere between 26 and 27. All right, so this next part, this is using function notation. So when you see these, what you should look for, this is basically saying you have 2 equations. One equation is y equals x plus 2. But that only is going to occur if your x value is less than or equal to 1. The other equation is y equals 3. Excuse me. So this only occurs when x is greater than 1. So you have to choose which equation you're going to use. So when you see evaluate the piecewise function, this is 2 separate problems. So let's look at which equation are we using. When x is negative 2, is negative 2 less than or equal to 1? Or is that x value greater than 1? All right, so is negative 2 less than or equal to 1? Yeah. So that's the one we're going to use. So this means use this one. So we're using y equals, or the quantity is x plus 2. Okay, so now I just need to put in the value that they give me, which is negative 2. So negative 2 plus 2, and that's 0. So my answer is 0. All right, x equals 5. Is 5 less than 1, or is 5 greater than 1? No, 5 is not less than or equal to 1, but it is greater than 1. So that tells me to use this one. Okay, so now this one is saying y equals 3. Well, it always is going to equal 3. There's nowhere to plug my x in. So any number that's greater than 1, if I plugged in 2, 3, 4, 5, 1,000, my answer would be 3. All right, last problem. So same thing. This time you got 3 equations to choose from. So is the number 4, is that less than or equal to 0? No. Is 4 in between 0 and 4? Well, yeah. It's greater than 0, but it's less than or equal to 4. So this is yes. If you try it in here, right, this is no. So there's only one that's going to work for. So this tells me I'm going to use this middle equation. So my actual expression that I'm substituting in for is 2x squared. So 2 times what squared? The number is 4. So that is 2 times 16, because you have to do 4 squared first, which is 32. All right, if you want to, you can do this in your calculator. So 2 times 4 squared is 32. All right, and then last one, negative 3. Is negative 3 less than or equal to 0? Yeah. So I know it's going to be that one, but just to prove that it doesn't work in the other ones, is negative 3 greater than 0 but less than or equal to 4? It is less than 4, but it's not greater than 0, so that's a no. Is negative 3 greater than 4? No. All right, so the only one it works for is this one. Okay, so I know I'm going to substitute 3x minus 1. The number I'm putting in is negative 3, so it's negative 9 minus 1, which is negative 10. All right, and again, if you want to use your calculator, feel free to do that. And if you have any questions on this stuff, make sure that you write them down, or like circle a problem, put a star by the problem that was hard. If there's something on that front page that you didn't get, then make a mark on your paper so that you can ask us tomorrow when you get to class.